In section 5.3 in our book, Unit 5, Pre-Calc, Learning Objective 6, we are solving exponential equations. And before we do problems starting at 61, I wanted to point out a couple things. Number one, you're going to be starting to see the letter E, or the number E, I should say. And I don't want you to be thinking about the number E as a variable, even though it's a letter. I want you to view it the way you would view even another irrational number like pi. So pi, we know that to be 3.14159 rounded here. Pi is just over 3, and on a number line you would see pi just past 3. Well, E is the number that you've learned of before, and E is a number just past 2.7. 2.718 is in a good approximation for the number E. And again, E is just a constant, and if we graph y equals 2 to the x, we would have this blue graph here. Y equals 3 to the x is the red graph, and then since E is in between 2 and 3, then E to the x would be a graph that would show to be in between the graph of 2 to the x and 3 to the x. So I don't want you to be confused when you see the letter E, or like I said, the number E. You'll start seeing that here soon enough, but I want you to treat it just the same way you would treat the number 3 or the number 2 or any other constant. We will not ever treat it as a variable. So that's the kind of like the bottom line there. And anyway, let's go ahead and start solving these equations. So problem number 61. We need to recognize here that we have an exponential equation, and the exponential equation because the variable is in the exponent. So that's why we have an exponential equation. And when we have an exponential equation, the one thing that's kind of nice here is that if we can create a situation in which we have a base on one side of the equal sign that's the same as the base on the other side of the equal sign, well, the only way that this equation would be true would be if the exponents are actually equal to one another. So we would say, therefore, x is equal to 3, and that's it. There's no work necessary for this one. So the concept for number 61, just understanding the concept, when the bases are the same, so let's write this down. Let's write concept. If the bases are the same, bases equal means exponents must be equal. Okay, so let's take a look and see how that impacts us here in problem number 63. So problem 63, and in future problems here, it's good to recognize when you have what your powers of 2 are, and 3 and 4 and 5. So those are the ones that we see most often. So here we see that the left side of the equal sign is written as 2 to a power, and the right side is not. The right side is 16, but if we know our powers of 2, we would know that 16 can be rewritten as 2 to the 4th power. And once we do that, now we have bases equal means exponents equal. So therefore, the opposite of x, the exponent on the left side of the equation, is equal to the exponent on the right side of the equation. And when we multiply or divide by -1, we see that x is equal to -4. That's it.